Hello, this is APRO RD. Today, we're going to take a look at the 3 cooling methods used after the HAST test is completed and understand the characteristics of each method. Chapter 1. Constant Humidity Slow Cooling. The first method is constant humidity slow cooling. In this mode, the chamber maintains the set humidity while the temperature is lowered gradually until it reaches 100 degrees Celsius. Because the cooling process is slow and controlled, this method is particularly suitable for humidity-sensitive samples and applications requiring maximum specimen protection. By maintaining a stable environment throughout the cooling process, both pressure stress and condensation risk can be minimized. However, this method requires the longest cooling time among the 3 cooling modes. Chapter 2. Cooling while keeping humidity. The second method is cooling while keeping humidity. In this mode, an external cooling fan is used to accelerate cooling while chamber pressure remains sealed and stable. This allows the chamber to cool much faster without exposing the sample to sudden pressure changes. As a result, it provides an excellent balance between cooling efficiency and specimen protection. Compared to Chapter 1, cooling time is significantly reduced, while pressure stress and condensation risks remain well controlled. For this reason, this method is commonly recommended for standard HAST reliability evaluations. Chapter 3. Rapid Exhaust and Venting. The third method is rapid exhaust and venting. In this mode, the exhaust valve opens immediately after the test is completed, allowing air and moisture to be released rapidly from the chamber. As a result, chamber pressure drops very quickly. Unlike the previous methods, this mode is not primarily intended to protect the sample. Instead, it is used to evaluate how much physical stress the sample and packaging can withstand under extreme conditions. Because of the sudden pressure release, weak structures may crack, deform, or fail during the cooling process. Therefore, this method is generally used for destructive limit evaluation rather than routine reliability testing. Chapter 4. Cooling Methods Comparison. Now that we've reviewed all 3 cooling methods, let's compare their key characteristics. Chapter 1 provides the highest level of specimen protection. Because humidity is maintained while cooling slowly, pressure stress and condensation are minimized. However, it requires the longest cooling time. Chapter 3 offers the fastest cooling speed. However, the rapid pressure release can place significant stress on the sample and packaging, making it more suitable for destructive limit evaluations. That brings us to Chapter 2. Chapter 2 combines the advantages of both approaches. It cools the chamber much faster than Chapter 1 while maintaining a stable pressure environment. At the same time, it greatly reduces the physical stress associated with Chapter 3. In other words, it provides the best balance of cooling efficiency, sample protection, and test productivity. For this reason, cooling while keeping humidity is generally recommended as the standard cooling method for most HAST reliability evaluations. Of course, the final cooling method should always be selected according to the test objective and sample characteristics. However, when a balanced and efficient solution is required, Chapter 2 is typically the preferred choice. At APRO RD Coaters Ltd, we provide a wide range of reliability testing services, including HAST testing, thermal shock testing, and various environmental reliability evaluations to support product qualification and quality assurance. If you have any questions regarding reliability testing or require technical support, please feel free to contact us at any time. Our experienced team will be happy to help you find the most suitable testing solution for your requirements. Thank you for watching, and we look forward to working with you.